To find the average cost function, we take the cost function and divide by x. For example, the cost of renting a cotton candy booth at a fair is $300. The cost of materials and labor for each item of cotton candy is $2. Write the linear cost function and write the average cost function for this situation. So starting with the linear cost function, the starting costs, no matter how many items are sold, is $300. That's the rental fee. Plus, for each item sold, the cost is $2 additional. So where x is the number of cotton candy items sold, C of x is 300 plus 2 times x. Now C bar is found by taking that C of x function and dividing by x. And we can leave it like this, or we could split it up into two terms, so 300 over x plus 2x over x. So that it looks more like a rational function, we'll leave the function like this, 300 plus 2x over x. Now using that average cost function, we're going to find C of 5, or C bar of 5 and C bar of 100 and compare those values. So C bar of 5 means what is the average cost for producing 5 items of cotton candy. And we plug in 5 to the C bar function above. So we get 300 plus 2 times 5 over 5, and that is 310 over 5, which is 62. And since this is average cost, that means that if we make and sell 5 pieces of cotton candy, the cost for each item would be $62. So $62 per item is what this average cost means. Okay, next let's find C bar of 100, so the average cost if we produce 100 items. So we plug in 100 to the C bar function. That is 300 plus 2 times 100 over 100. So that is 300 plus 200, so 500 over 100, which is 5. So $5 per item is the average cost. And what this means is that as the number of items increases, the cost per item decreases. So even though the cost function itself will increase as we produce more items, the average cost should go down for a linear cost function like this. And we see that it does. For producing 5 items, it's $62 per item, which is very expensive if you think about cotton candy. But if we make more cotton candy, so if we make 100 items, the average cost goes down to $5 per item. So finally, let's think about the horizontal asymptote for C bar of x. Now, algebraically to find the horizontal asymptote from what we've learned about rational functions, we can think of only the highest power of x terms and reduce them. So that would be y equals, we ignore the 300 because it does not have an x. It's not the coefficient of an x. We get y equals 2x over x. The x's cancel and we're left with 2. So y equals 2 is the horizontal asymptote for this rational function C bar. Now, the reason that makes sense is if we think about the horizontal asymptote, that means what happens as x gets really, really large. So as we make more and more items, the cost of making each item is going to get closer and closer to the cost per item, which is $2, because the fixed costs are $300. So think about if we make 1,000 items of cotton candy, the fixed cost per item is just $300 over 1,000, which is really small. So the cost for making each item would be just $2 plus that small fraction. So as x gets larger, the number of items get larger. The average cost is going to get closer and closer to that cost per item in this situation, which is 2.